Hey folks, Mr. B here again, bringing another wicked awesome math video. This video is on doing the limit of when an absolute value function is involved. So I'm getting a few complaints that my videos have been a little bit, as my students put it, out of pocket lately, which means cringe. So I'm going to keep this one tame. But as always, if you like this video, please hit like, and please, if you're not already subscribed, please subscribe. And I hope that this video can help you in some way. And this is just another video in my calculus series, so I'm trying to up the quality of my content, but apparently I have failed miserably. So anyway, let's get to it. All right, so hopefully now you can see in front of me, in front of you, that we have a limit. And we have an absolute value on the top, which is x minus 4, and on the bottom we have x squared minus 16. Well, these absolute value limits are actually a little challenging, but not for like the difficultness of actually factoring them or anything like that, but more for trying to decide what to do with this absolute value. So somewhere along the lines, you guys should have learned that an absolute value is actually a piecewise function, and it has two pieces. It has the positive piece, x minus 4, and it has the negative piece, which is negative x minus 4. So it has the positive piece and the negative piece. So where this comes from is an absolute value has a V shape. So this absolute value has the V shape. So it has, let's see, so it's right here. So it has this, I'm going to get this wrong. It's actually the x-intercept is here, so it looks like this. I'm just about to put it in the wrong spot, and luckily I did not. So let me just erase that dot. So we had to decide that didn't work at all, did it? Let's try again. Here we go. Get rid of that guy and get my pen back. So we had to decide what piece belongs to what side. So in general, what's going on here this evening? So in general, we have the x. I'm having some technical difficulties. Here we go. This is the positive slope side, and this is the negative slope side. So the reason why it's the positive slope side and the negative slope side, obviously, is because the absolute value function is just two lines connected together. One has a positive slope, one has a negative slope. So I know this is the negative slope side right here. That is the negative slope side, negative x minus 4. And over here, this is the positive slope side, x minus 4. So we had to decide which one of these pieces is actually going to go here with the limit. Well, you notice here what the limit says. That little minus sign means that it's on the left-hand side of 4. All right, so 4 is right here. That's our x-intercept. So the left-hand side is this guy, which is the negative slope side. And the right-hand side would be this guy. So this is the 4 minus side, and this is the 4 plus side. So we need to decide what one we're going to use. Well, by breaking this absolute value up into its two pieces, we can interpret what is going to happen. Now, I'm going to give you another little trick for this in a second, but we're going to go with the theoretical way, then we're going to go with the Barnes way, all right? So this is a theoretical way, which is to logically think about what side is going to have that negative slope. So, my goodness gracious. All right, so let's do the limit. And so we decided that the left-hand side is this particular side with the negative slope. So all I do is put negative x minus 4 here, and at the same time what I'm going to do is I'm going to factor the bottom. So I'm going to go x minus 4, x plus 4. So again, the reason why I couldn't just sub this 4 in is because it's indeterminate form. So if I sub this in right away, I would have got 0 over 0, which means I have to do something else, which is factor, things like that. So now that I've factored, I can go ahead and cancel out my indeterminate form here, my removable discontinuity, my x minus 4, and then I'm going to rewrite limit as x goes to 4 minus, and I'm left with 1 over x plus 4. So once I get rid of that Now this minus doesn't really mean a whole lot, but I will still put it in there, and generally I do this. I don't know how other people feel about this, but I kind of do that, and it really only matters in one situation. Maybe I'll get a chance to explain in this video. And in this case, it doesn't really matter because it's just 4 plus 4, which is 8. And I end up with 1 over 8. So that's like the theoretical way to do it, even though I fumbled up along the way. Really, how I do it is that when I pick the sign, this is my little hint to remember it, right? So the minus here should match the sign on my x. All right, so if I have a negative here, it means I should have a negative slope on my x. All right, so we'll keep that in mind as we do the next one. So the next one, I've got the limit as x goes to 2 minus. So again, that's 2 minus means the left-hand side of 2. So you're thinking like 1.9, 1.8, things like that. So again, I have two choices. And again, I'm ignoring this negative. This negative doesn't have anything to do. And what I tell my students a lot of times is just forget about that negative that's hanging outside the absolute value, and then write it down there so it doesn't even come into play. You're not even thinking about it right now. You'll worry about it after. So you're thinking about this. So there's two possibilities for this situation. So there's just drop the absolute value and you get left with that, or you drop the absolute value and you put a minus outside. So again, you have to kind of consider the situations. So when you think about the graph of negative x minus 2, or the absolute value of it, again, it's a V shape. It has an x-intercept at 2 right there, and it would look like this. So then you think about this is the negative side, slope side. This is the positive slope side. So when I think about which one of these belongs to the left-hand side, this is the one that has the negative slope, right? So that's the 2 minus x. This has a positive slope. If I went in with this, I would have, that's basically x minus 2. So that's the positive slope. So this belongs to this side, x minus 2. So in terms of what I want to replace this absolute value with, all I need to do is choose one of these things. And that one right here is the negative side. Since we're on the negative side, we choose this one. So I end up with x 2 minus, and then that negative again. I'm completely ignoring it. So I dropped my absolute value signs. I picked one of these. And what do you notice is that this sign matches the sign on this x. We're ignoring that negative. That negative does not come into play in making our decision. Only what is what's inside the absolute value. So that negative matches that. So now I'm ready to go ahead and solve this. So I'll go limit as x approaches 2 minus. And now what I'm going to do is I'm going to distribute through this negative. So that negative is going to go to that, but it's also going to go to this. So it becomes x minus 2. Then we do x minus 2 on the bottom, x plus 2, and then these end up canceling. And then I'm ready to sub in I'll rewrite first as x goes to 2 minus, and then 1 over x plus 2. And we go ahead, sub in 1 over 2 minus plus 2. Again, that minus doesn't really matter in this situation, and we end up with 1 over 4. So I really hope that's a little bit clear in terms of what we do when we're selecting. Now I've got one more example here that I want to go through. And again, guys, I'm going a little bit quick, but I'm trying to keep these videos on the shorter side. So if you need to like rewind or go back, feel free to do that at any point in time. I've got another example, and this one's a little bit different. So the reason why this one is different is because you notice here there's no little plus or minus. So it doesn't specify left-hand side or right-hand side, which means we need to do both. So we need to do the left-hand side, and then we need to do the right-hand side. So I'll take the limit as x goes to negative 2 minus, and that's the left-hand side. And I won't decide what I'm going to do with this yet. And then over here, I'll do the same thing. The limit as x goes to 2 plus. of x minus 2, absolute valued, x squared minus 4. So the first thing I'm going to do is I'm going to make a decision on what's happening here. So let's go ahead and think about this logically and use a little trick. So inside my absolute value, I have x minus 2. So this represents the left-hand side. So this is the negative slope side. So right now, this thing has a positive slope inside the brackets. So what I'm going to do is I'm going to use the second version of it, which is the negative on the outside. So when I distribute through with that negative, I can match the slope of this with the left-hand side, meaning it's a negative slope. Then all I need to do is I just factor the bottom, and these end up canceling, just like that. And I can go ahead now and I could sub in this guy. So this is where this thing gets a little bit interesting. So this is the example I was talking about where it matters about the that little minus sign right there. So I'll go ahead and sub, and I got negative 2 minus plus 2. So this is really important that you guys recognize what's happening here. So on the bottom, I've got something on the left-hand side of negative 2. So when I'm doing this, I think about like what is a good number to think about on the left-hand side of negative 2. So I might think about negative 2.1 or negative 2.01. But more importantly, what I'm thinking about is what's the sign of the bottom going to be. So if I went and turn this into negative 2.1 and I add 2 to it, I end up with a negative 0.0, not 0.1, just negative 0.1. So if I do that, the bottom is going to be negative. It doesn't matter how much closer to negative 2 this thing gets, it's still going to be negative. Even if it was negative 2.0000001, it's still slightly negative. So the way I write this is I would go negative 1 divided by almost 0, but it's a slightly negative number. So really small negative number. And then when you do that, a negative divided by a negative is a positive, and in fact, it becomes positive infinity. Because this is a really small number. 1 divided by a really small number is infinity. In this case, positive infinity because it's a negative over a negative. All right, that was a mouthful. Now the next one, I'll do the same thing. So I've got the positive slope side. So I want my x to have a positive slope. So in order, it already has a positive slope, so I can just drop the absolute value. Then I'll factor the bottom, negative 2 plus 2. And there should be a minus 2 on that, I think. Yep. Okay. These cancel, just like that. And I'm left with the limit as x goes to negative 2 plus. That's 1 over x plus 2. So again, I'm going to sub now. 1 over negative 2 plus 2. So negative 2 plus, you have to think about the right-hand side of 2. So negative 2 plus is like the equivalent of negative 1.9. So if I go negative 1.9 plus 2, I have a slightly positive number on the bottom. And then a positive over a positive is a positive infinity. So now we can sort of make a conclusion overall about the limit. So we know the limit doesn't exist because obviously the one-sided limits are infinity, but we can actually say that the overall limit tends in that direction. So negative 2 plus, or sorry, negative 2 just overall. Let me see if I can erase this. Eraser. Here we go. Now let's see if I can get my pen back. Here we go. And it's absolute value of x minus 2 all over x squared minus 4 equals infinity. So there it is, everyone. Hopefully I managed to shine some light and not confuse two people, even though I kind of confused myself during this video, on how to do absolute value limits. Really, you need to try and make sense of this in your own head. And that's one thing that I find is that students find it difficult trying to decide what side to pick. Do I drop the absolute value and don't put a minus, or do I drop the absolute value and put a minus? You've got to come up with a scheme in your head that works for you. Hopefully this video helps you create that scheme, but you have to do it yourself. All right, guys, as always, if this video helped in any way, I would really appreciate you dropping a like, a share, comment, or a subscribe. And thanks for watching, and I will see you guys in class.
It's over. Go home. Go.